Hey guys, I am outside again, and this time I've been out doing some yard work, and I've been doing some limbing, cutting some limbs off some trees, and been using my ladder. And I wanted to kind of share this with you because I thought it was very geometrical and mathematical, and it's probably something that you may be interested in. You certainly could use in math class and probably in real life at some point. Take a look at it. That is my ladder. One of my ladders, and it is in need of a wash. However, that's not what I wanted to show you and demonstrate to you. What I am getting ready to do is going to require me to actually climb up this ladder at some point, and I just want to let you know that this is not something that I recommend you do at home without supervision and without the proper training and equipment. You guys have to keep in mind that I am a trained math teacher. I'm a professional math teacher, and this is something that I often do, and I have the experience and the knowledge and the proper equipment to do it with. So keep that in mind. I don't want you to try this on your own because it could present a safety hazard. The ladder that is against the tree is extended out to exactly 17 feet. And the base of the ladder that's on the ground is exactly 6 feet from the base of the trunk of the tree. The question that occurred to me was, well, how far then is the top of the ladder resting against the tree? If the ladder's 17 feet and it's 6 feet out from the tree, it's at an angle, so it can't be exactly 17 feet. So how far up the tree is the top of my ladder resting? Now, if I wanted to find out how far up the tree my ladder is resting, and I did not want to actually measure it, then I could use what's called the Pythagorean Theorem, which is a squared plus b squared equals c squared, where a and b represent the legs and c would represent the hypotenuse. In this case, my ladder would represent c, the hypotenuse. The distance from the base of the ladder to the tree would represent one of the legs, and then from the base of the tree straight up to the top of my ladder where it's resting would be the other leg. Here's a diagram of what I just described. The position of the ladder, tree, and ground form what appears to be a right triangle. This being the case, we can find out just about how far up that tree my ladder is resting. We will use a squared plus b squared equals c squared, where the a and b represent a leg length and c represents the hypotenuse. Replace b with the value of 6 and replace c with the value of 17, and then simplify. We will then subtract 36 from both sides of the equation, resulting in a squared equals 253. The last step is to take the square root of a squared and the square root of 253. This results in a is approximately 15.9 feet. So by my calculations using the Pythagorean theorem, apparently my ladder is resting 16 feet up the tree. I'm going to go check. Well, it's confirmed. The measurement is 16 feet. Maybe a couple inches different, but I think the ground is not quite level here. So anyway, it works. Okay, this next one is for you. What I've done, I've reset my ladder against a different tree. My ladder is still extended out to 17 feet, but this time I put the base of the ladder 8 feet from the trunk of the tree. So I'll show you this. There it is. Now, what I want you to figure out is how far up the tree is the top of my ladder resting. Again, the ladder is extended to 17 feet. The base of the ladder is 8 feet from the tree. How far up the tree is the ladder resting? Pause the video here to calculate, then unpause to check your answer. And just a word of caution, never trust a ladder. They're always up to something.